Yep. Okay, hello guys, students, how are you? Okay, welcome to my channel Study Hub. Today I will discuss about the thermodynamics part 6. Yesterday I discussed about the enthalpy and also the first law of thermodynamics. Today I will discuss about 2 or 3 numericals regarding enthalpy, and then I will start the heat capacity. Okay. Specific heat capacity, molar heat capacity, and so on. So before that, so be happy. Please, I'm Shankar sir. So please subscribe me. I always need your support. Basically, from the beginners, I am the beginner now, and I always expect your supports. And please, all of you, subscribe it and share it to your friends, and also share my views towards your friends. Thank you. So let's start.
अगर तुम लोग नए हो तो सब्सक्राइब करो, वो जो लाल वाला बटन है उसके साथ स्कैम करो या फिर महफिल जमाओ, मुझे नहीं पता, बस क्लिक हो जाना चाहिए.
So guys, now let's start. Whatever in my part 5 video, I have discussed about the enthalpy and enthalpy change, and also the internal energy change. Now, what we learned in the previous history, the H equals to is enthalpy, U plus internal energy plus PV. Okay, from here delta H, the change of enthalpy, equals to delta U plus delta PV. This is the important formula I have told earlier. And also delta H equals to delta U plus P2 V2 minus P1 P1. Final velocity in volume into pressure minus initial velocity into pressure volume. And next delta H equals to NCP delta T. Yesterday I have discussed about this. Also this portion I also discussed in case of heat capacity also. Okay, so let's start 2 or 3 numerical problems. Okay, first numerical problems, it is given, suppose a gas, okay, a gas may be ideal gas, maybe non-ideal gas. And say out here it is non-ideal gas, okay, the non-ideal gas, it is a non-ideal gas. Okay, a gas in the piston is given and it is shifted from state A to state B. Suppose non-ideal gas, okay, shifted, goes from, it is changes from the state A to state B. Clear? And what is the condition of the gas of the condition at state A? Suppose its initial pressure equals to 4 atm, initial pressure 4 atm, or its initial volume equals to C 5, initial volume equals to 5, maybe 5, okay, or temperature maybe 90 K, okay. So what is the volume liter, okay, and final in state B, the P2 because that is P1 V1, okay, and P2 suppose it is 8 atm, change हो गया, V2 वॉल्यूम हो गया, okay, 5, it is 6 कर दो, it is कर दो 7 liter, okay, temperature 95 K, okay, or 135 K, 105. Okay, so state A में condition का pressure था, volume था, temperature था, okay, and state 2 में pressure volume change हो गया, okay, and temperature भी change हो गया out here. So if you ask to find find change of enthalpy, find enthalpy change, and if in this condition, if it is given delta U, if it is given delta U or delta E, it is given say 40 or 30, whatever it may, 40 liter. Okay, it is atmosphere liter, it is given. Atmosphere atm liter, it is given U. Delta U by delta E is given 30, 20, 40, whatever it means. Suppose I am given an example. And how you will do the you have to find out the delta H. Delta H you have to find out. Delta H. Okay. So in the formula, what is delta H? You know delta H. What is the delta H? You have to find out the delta H equals to delta U plus delta PV. Delta PV or delta PV cover you can write out here P2 V2 minus P1 V1. You can write out here delta U plus P2 V2 minus P1 V1. You can write. So put the value. What is out there? 40 plus P2 V2, that means 6 into 7, 42 minus P1 V1, 20. Clear? So 40 plus here कितना होगा 2 22. Clear? 2. So it will be 62 atm liter. This is the answer. Okay, this is atm liter. So delta H, that is the change of enthalpy, is 62 atm liter. Clear? So this state may have and this state. So compare the conditions P1 V1 P2 V2 and apply this formula and find out the solve. Okay, so it is very easy. Clear? Picture? Write it down. Okay. So a gas expanded isothermally expanded. Okay, suppose from 2 liter to 14 liter. Clear? 14 liter at 25 degrees centigrade. Plus find delta H. Clear? What is find delta H? Clear? So what will be the answer? But sure, there will be so many options are there. Option will be given out here. I am not giving the options. Okay, direct I am giving the answers. So find a gas expanded isothermally 2 liter to 40 liter at 25 degrees centigrade. Find delta H. Clear? How? So find delta H equals to what? Delta U plus delta PV. We know delta H equals to delta U plus delta PV. Clear? The delta PV and delta U क्या दिया है यहाँ इसमें only volume change 2 liter से 40 liter and constant temperature, that is isothermally. So how will you apply that and put the value? One thing you must remember out here, in case of it is ideal. Sorry, that is non-ideal gas. It is the ideal gas. It is an ideal gas. Okay, a gas ideal gas. So in case of ideal gas, what you know, I have again and again told you, but confirm you that in case of at constant temperature, and at constant temperature by isothermally, delta U at constant temperature, delta U change of internal energy always 0. Isothermal always 0. And in also we know P1 V1 equals to P2 V2 at constant temperature. Yeah, at constant temperature P1 V1 equals to P2 V2 and delta U equals to 0. So out here we can write here 0 plus. In case of delta PV, that means what to write? P2 V2 minus P1 V1, as it is 0, so 0 plus 0, that is 0. So change of enthalpy equals to 0. Very important sum. There will be given so many things, only 0 and innumerable numbers are there. So this option will be correct. Clear? So next.
Last one. Hello, hi guys. Welcome to my channel. Study on series, studying. Your subscription makes me happy and I'm happy. I need this every out, so let's start.
कैसा लगा मेरा मजाक?
So this one and this one completed, and now in this formula, first I have told you which will have to apply. I do not require to tell. Say 2 mole of gas. 2 mole of a gas. Say any monatomic gas, say helium, neon, anything. 2 mole of gas helium is heated, okay, and from 0 degrees to 50 degrees centigrade. 2 mole of gas is heated, helium, heated, strongly heated from 0 degrees centigrade to 50 degrees centigrade, about 40, 60, whatever you can write, centigrade. Okay, beautiful. 500 to 5 to 50, whatever you can write. And find delta H. You have to find. Right. 2 mole of a gas, say helium, monatomic gas, diatomic gas, anything is heated from 0 degrees centigrade to 50 degrees centigrade, and in this case you have to find out delta H. How you will find out? Bolo. In which formula you will be? Here is not given anything. Not delta U, not P, not P1, not P1, not P2, not V2. How will apply? Okay? Yeah? So tell me. Yeah? Okay. Nothing? Okay. Hello. Here, it is heated. See, what we will have to do in this case, what we know out here, see, delta H equals to N, moles, 2 moles of gas. So what is the N? Number of moles. What is Cp? I have discussed its capacity, and that is delta T, change of temperature. So number of moles out there, you know, in that case you have to use in this formula NCP delta T. NCP delta T. And I have told you in the yesterday classes, yesterday video, part 5, that is F. What is Cp? How to find out the value of Cp? You have to find out the value of Cp. You have to find out the value of Cp. How? Cp, I will come the next part. The Cp equals to 1 plus F by 2R. This is the formula. I have told you about the F, degree of freedom. Degree of freedom I have told. And you know the value of R. Okay. 2 moles, 2 calorie per moles per mole Kelvin, or 8.3145 joule per mole Kelvin. Okay. Any one of the 2 value you can put. In case of calorie, you have to put the value of R equals to 2 mole, 2 calorie. Suppose here F. In case of monoatomic gas, you know, in case of monoatomic gas, I have told you, they have to apply what is the value of F, you know, 2 by 3. Yeah, 3 by 2. 3 by 2. In case of diatomic gas, you know, the 3, the 5, and polyatomic 6. So, in that case, out here, N equals to 2 moles, clear, 2 into, the Cp means 1 plus F by 2, okay, so 1 plus F by 2, F का value out here कितना होगा? 2 by 3 का 3 by 2, yeah, 1 plus 3 by 2 into R into delta T. Delta T का मतलब क्या होगा? Delta T, that means 50 minus 0, that will be 50. Okay, so what will be the value? 2 plus 3, 5 by 2. So 2 into 5 by 2 into R into 50. Yes, this answer. If you convert the answer 2 into 5 by 2 into 8 point, if you find the value of, in case of joule, 8.3145 into 50. You have to write joule per mole Kelvin. This is this is joule. Here is joule. This will cancel. So answer will be in joule. Whatever the answer, you can write out here. Okay. This is the answer. And calculate it and write the answer. So for the mind, remember, here you have to apply this formula. Cp equals to 1 plus L by 2R. And R equals to this. In case of calorie, you have to value of R equals to 2. Okay. So here's these are some of the numerical examples. I'll also do more details in the next. So next. So now next I will discuss about heat capacity. Heat capacity क्या है? Then specific heat capacity and then molecular heat capacity. Heat capacity capital C, specific heat capacity small c, molar heat capacity Cm. इसका बाद और कुछ है, I will discuss. Okay. So what is heat capacity? So today just I will discuss about this thing. Heat capacity. So in this chapter, we focus on the measurement of heat change. The measurement of heat change. Heat change का measurement क्या होगा? उसी का जो discussion होगा वो है heat capacity. The heat transferred to the system appears to rise in its temperature. The heat capacity, that is the heat transferred to the system, appears to rise in its temperature. The increase in temperature, that is delta T, is directly proportional to the quantity of heat absorbed by the system. The increase in temperature of a system, suppose एक सिस्टम है, इस सिस्टम का हीट इंक्रीज होगा, वो डिपेंड्स करता है इसके ऊपर, जो क्वांटिटी ऑफ हीट एब्जॉर्ब बाय द सिस्टम. जितना वो एब्जॉर्ब करेगा उतना ही उसका हीट इंक्रीज होगा. That is if we write that if quantity of heat is Q is directly proportional to the delta T increased temperature. Clear? Increased temperature. Clear? That is Q raises dt. That is directly proportional to the heat absorbed. Clear? In this case, if you do Q equals to variable equals to n constant C delta T. Q equals to C delta T. What is C? C is the heat capacity. C is the heat capacity. Clear? C is the heat capacity. So here we can get C equals to what? Q by delta T. C equals to, that is the heat capacity, equals to Q by delta T. Clear? In this case, this is the definition of heat capacity. Okay? Here heat is absorbed. So by the system, it is absorbed by the system. So here always be positive plus Q. You can tell plus Q by delta T. In case of, if this delta T, the temperature difference is unity, it is 1, that is 1 degree centigrade or Kelvin, that is delta T equals to 1, then we can say C equals to what? C equals to Q. Clear? C equals to Q. If this is, that is delta T equals to this, then C equals to Q. That from this we can get the definition of heat capacity. Heat capacity equals to Q. So now the definition of heat capacity from here. What is the definition? C. So see, don't require to just go through reading not required. What is the definition of heat capacity from this equation? You can readily be tell. The heat capacity what? Heat capacity of the system. Heat capacity of the system is the quantity of heat required. Quantity of heat required to raise its temperature. To raise its temperature through 1 degree. Kelvin or centigrade. That means heat capacity is the of the system is the quantity of heat required to raise its temperature through 1 degree centigrade or 1 Kelvin. Clear? The definition of heat capacity. Clear? And this definition is useful in all these cases. Just only one word will be changed. Heat capacity of the system is the quantity of heat required to raise its temperature by 1 degree centigrade or 1 Kelvin. Now, something about the heat capacity. What we learn from heat capacity, it is the quantity of, that the amount of heat is required out here. Amount of heat is required. So, heat capacity is, it is the intensive property. It is the intensive property. Now, extensive property. Tell me. Extensive, yes. Extensive. Extensive property. Clear? The heat capacity is the extensive property. But is the state function or path function? It is the state function or path function? It is not the path function, it is state function. Okay? Yes. And also the unit. From here you can calculate the unit. What is the unit? Unit will be unit of heat and unit of temperature change. So unit will be, all you remember out there, unit of this and unit of this. So unit of this what? Joule. Okay? It is joule per Kelvin, joule per degree centigrade, calorie per degree centigrade, joule per degree centigrade, whatever you can. And Q by delta T, the joule per Kelvin, joule per degree centigrade, clear? Calorie per degree centigrade. So unit is, you can, what you can write? Calorie per degree centigrade, joule per degree centigrade, joule per Kelvin, whatever you can tell. Okay? The heat, extensive property, state function, unit, clear? Now next come specific heat capacity. What is specific heat capacity? Same thing. From this here, from here, we can write the specific heat capacity. Specific heat capacity is the what? Same thing, that is heat required to change. The same thing, to raise its temperature of 1 degree centigrade or 1 Kelvin of 1 gram of any substance. 1 gram. इसमें 1 ग्राम 1 ग्राम के लिए उसका 1 डिग्री टेम्परेचर व केल्विन उसका रेज करने के लिए जो अमाउंट ऑफ हीट इज रिक्वायर्ड, दैट इज द स्पेसिफिक हीट कैपेसिटी. ओके, इट इज ऑल्सो पर्टिकुलर 1 gram. So this doesn't depend upon the amount of matter. Okay, so it is the intensive property. It is intensive property. Intensive property. Yeah? Intensive property. Unit will be same. just like the heat capacity. Heat capacity. So before unit, I am going to the definition. From the definition, what we get out here, what we see out here, the same thing. Raise 1 degree centigrade or Kelvin of 1 gram of any substance. Okay, that is C equals to C by M mass, M gram mass. Okay, from here C equals to what? I have got C equals to what? If I got C equals to Q by delta T, from here C equals to Q by delta T. So here C equals to Q by M delta T plus Q by C delta T. So specific heat equals to Q by M delta T. So what will be the unit out here? In this case, what are the unit? The same thing out here, degree joule or calorie, anything, joule per degree centigrade, joule per Kelvin, calorie per degree centigrade, calorie per Kelvin in case of heat capacity. So out here, same thing will be out there, joule, gram inverse, joule per gram per gram, joule gram inverse, Kelvin inverse, whatever you can write. Okay, joule, gram inverse, okay, degree inverse, whatever you can write, of the only there will be gram. There is M, joule per degree centigrade, joule per Kelvin, joule per gram, per gram per Kelvin. So that will be in case of mass will be added there, unit of mass. Okay. So Q equals to Q by M delta T. Specific heat equals to plus Q by M delta T. Okay. This is the specific heat capacity. Next. Now molar heat capacity. Molar heat capacity. Same thing. The same definition out here. Out here per gram. Here to raise the temperature of 1 degree centigrade or Kelvin of through 1 mole of any gas. 1 mole of gas. Yeah, 1 mole of gas. Same thing. 1 degree centigrade or Kelvin increase 1 mole of any gas. Definitions are same. The all are same. So it will be 1 gram. It is 1 mole. 1 mole of any gas. So in this case, what we get out here? Cm we can express this small c, capital C, and it is Cm, specific heat, molar heat capacity, Cm. It is equals to what we got, C by N, number of moles. So C means Q delta T, here C means Q by delta T, N, that is the N delta T, that is the Cm equals to Q by N delta T, Q by N delta T. This is the, so we can express molar heat capacity by Cm. That is Cm equals to Q by N delta T. Here C equals to Q by M delta T. Here C equals to Q by delta T. Q by delta is this one. Here this. Oh, so 1 mole of gas, yeah, 1 degree centigrade or 1 Kelvin, you have to increase, and it is the calorie, same unit, this is the calorie, per mole inverse, degree centigrade inverse, calorie per mole inverse, degree centigrade inverse, calorie, in case nakali joule per mole inverse per centigrade inverse, joule per mole inverse by Kelvin inverse, whatever you can write as unit. So unit don't require to remember in this way. If you remember this, so from here you can write the unit of the molar heat capacity. Okay. So Cm equals to what we got out here, C into mass, molar mass. C into molar mass, specific heat capacity. So molar heat capacity equals to molar heat capacity equals to specific heat capacity into molar mass. then into molar mass. You can write specific heat capacity into molar mass. Specific heat capacity is given. You can find out the molar heat capacity. Okay. So in short,
A few moments later.
okay. So now we look at these things at a glance. What is CP, CV, CPS, CVS, CPM, CVM, and all these things I will discuss. I also discuss also later classes. Now I am discussing what is CP. CP means the heat capacity at constant pressure. Heat capacity at constant pressure. What is heat capacity? Q by delta T. We know. So what is the constant at it is constant pressure? So CP equals to QP by delta T. So it is the heat capacity at constant pressure. And next, in same thing, CV. CV, heat capacity at constant volume. That is the QV. You have to write out the QV means constant volume. Okay. QV by delta T. Same thing, CPS. CPST, specific heat capacity. Specific small c, specific heat capacity at constant pressure. The QP by M delta T. What I learned in the previous discussions. CVS, same thing, specific heat capacity at constant volume. Specific heat capacity at constant volume. QV M delta T. Here QV, V means constant volume, P means constant pressure. Constant pressure, constant volume. Nothing else. All we learn up go. This is the same thing. Only constant pressure, constant volume. Clear? So out here CPM, P dot M. It is molar heat capacity. Capital C. Molar heat capacity at constant pressure. QP by N delta T. What we learn? Molar heat capacity Q by N delta T. Molar heat capacity at constant pressure CPM, that is the QP. Same thing CVM, molar heat capacity at constant volume QV by N delta T. All are same. Okay, so learn these things. We know Q equals to C delta T and Q equals to also Cn delta T. Here is specific heat capacity. This is the mass, the temperature difference. Okay, so from this we can learn Q equals to C delta T equals to Cm delta T. So we can learn Q equals to Cm delta T equals to C delta T. Okay, so this is the relation. We have to know this. Okay, so next come what is the relation between Cp and Cv. I am coming relation between Cp and Cv. Okay. Now what we done discuss about the relation between the Cp and Cv. What we learned from the yesterday table, we can out here the difference relation between Cp and Cv. Specific heat at constant pressure and constant volume. Okay. Specific heat capacity at constant pressure and constant volume. The relation. What do you know from the specific heat from the earlier discussion? C equals to Q by delta T. You know clear. Cp equals to what you know? QP delta T. Cp equals to QB by delta T. We know out here. For ideal gas, what you know? Delta T equals to 0. Delta equals to 0. We know. Clear? And also QP equals to delta H. QB equals to delta U. Then it is the enthalpy change. Enthalpy in case of internal energy. We know this. So what we have to write out here. Now how to consider the relation. Okay. So CV. Out at CV, because QV by delta T. Okay, what do you know? CV equals to QV by delta T. Clear? We know Cp equals to what? QP by delta T. We know. Just a few minutes ago, we have written in the table. What is QV? QV equals to what? Delta U. So QV equals to delta U by delta T. Because QV equals to delta U, we learn. And what is QP? QP equals to delta H. It is delta H by delta T. So CV equals to delta U by delta T. Cp equals to delta H by delta T. So QCV delta U by delta T. Cp equals to delta H by delta T. We know out here. What do we know out here? Again, we know H equals to, we know enthalpy. H equals to plus PV. U plus PV. We have learned enthalpy. And also we learned H equals to U plus PV equals to what? nRT in case of ideal gas. PV equals to nRT. nRT we learned. So here nRT H equals to U plus nRT. We can write out here. Okay. So if you differentiate this, H equals to U plus nRT. The differentiation that means dH by dt, du by dt plus nR. Okay. dH by dt equals to dH by dt. Yes, out here. If you differentiate out here, dH, that is dH by delta T by dt. You can write dH by delta T equals to du by delta T plus, clear? nR. Clear? You can write out here. Temperature constant. So in this dH by dt, what do we write? dH by dt, Cv. That is Cp. From here, we can write Cp equals to, clear? It is Cv plus what? This is nR. So Cp minus Cv equals to nR. This is the for n mole of gas. In case of 1 mole of gas, we can write Cp minus Cv equals to R. This is the relation. For 1 mole of gas, this is the relation. So Cp equals to R minus Cv, R plus Cv. You can write also. This is the Cp minus Cv equals to R. So this is the relation. Do it and it will be very helpful for your numerical problems. So here I draw my ends. So please subscribe and or follow my channels regular basis, and from this now I hope this will be a crystal clear of this up to chapter part 6. If any problem, ask, inquire what you know. So goodbye. Okay.
खत्म, बाय बाय, टाटा, गुड बाय, गया।